The previous videos, we mentioned about the heavy structure lab as one of the facility used to conduct full-scale structural testing for civil engineering structural elements. We mentioned about various components in the heavy structure lab and also introduced you the strong floor system. There are other elements in the heavy structure lab, which is the strong wall system. The strong wall system is similar to the strong floor system. It also has a lot of fastening points, only that the strong floor is a slab and the strong wall is a wall. This is a structural wall which is meant to resist the lateral load. Normally there will be actuator system being fastened to the strong wall. As reflected in the figure here, this is a typical strong wall. There are a lot of fastening points for the installations of the actuators. This is another example of the strong wall. You can actually install a series of the actuators onto the strong wall, where you can use this actuator to simulate horizontal load acting on the test structures. Its function is to provide lateral resistance to the lateral load exerted by the actuators or the hydraulic jack system during the testing, and its function is not to transfer those loads to the building structures. You don't want to cause any unnecessary damage to the building structure. In terms of the installations as well as the considerations for the strong wall system, it will be quite similar to the strong floor system. Next, we discuss about the portal frame system. It is a frame system normally made of standardized steel section, where the members have a lot of holes prefabricated for the installations of the bolt and nut system at anywhere along the member, and those members are assembled together to become a frame and to provide mechanism to support the specimen and to exert loads onto the test specimen. These are the typical portal frame system. It is basically an assembly of the standard size steel sections installed for stabilizing the test specimen as well as positioning of the hydraulic jack system that imposing loads onto the specimen. Normally, as a precautions to prevent the loads exerted onto the specimen affecting the positioning of the specimen, the assembly of the portal frame, which are used to stabilize the test specimen and impose the load onto the test specimens, needs to be separated. You know that the steel structures, when subjected to the load, there will be deformations. Even those slight deformations can affect the accuracy of the experiment being tested. Taking this as an example, the researcher intends to test the connections for a typical T subframe system, which involves a column and a beam. There will be a vertical load being applied onto the specimen, and this T subframe system needs to be put in the upright conditions without any rotations in order to test the rotational resistance of the connection here. There will be two portal frames here. One is used to stabilize this test specimen, preventing the rotations of this specimen. Another one is for the hydraulic jack system to apply loads onto the specimen. It is a good practice to separate these two portal frames, as applying the load onto the specimen may lead to the lateral movement of the specimen, and this can affect the verticalness of the loads applied as well as it will affect the accuracy in terms of the result that you acquired. Since we are talking about the rotational resistance here, the load being applied is in terms of the vertical force. We will need to convert this vertical force into the moment rotations at the connection joint. Imagine that if the structures move slightly in terms of the deformations caused by the Porter frame, as well as slight movement in terms of the actuator here, the computed moment acting at the joint here might not be as accurate. For the frame system here, it will require lateral bracing, and for the vertical loop here, the Porter frame will need to resist the loops generated by the actuator system. The same principle applies to this setup. There will be frame which is used to support the structure, brace laterally, and there will be another Porter frame to apply loops onto the specimen without actually connected to the frame that is used to resist the movement of the specimen. That is the whole idea of the Porter frame system. This Porter frame is actually an assembly of standard size steel section. Those sections can be in the form of C channels, I sections, H sections, angle, which is mainly used for bracing, and also the compound sections, which are mainly used as the base of the structures. And all these will have holes built in within the section. This is allowing for the installations of the bolt and nut system, joining the structures element at any place along its member. This allows the flexibility in terms of the setup of the Porter frame. And normally the spacing of the bolts are typically 100 mm center to center. Again, when you want to use those for the installations of the Porter frame, you will need to check the accuracy in terms of the bolt holes. Some may be off slightly, which leads to difficulty of assembly of the Porter frame. Sometimes the members itself does not come in the perfect straight line, which is slightly bent, leading to the inaccuracy of the bolt holes, and it will affect the installations of the Porter frame. You will have to be careful of this as well. And during the installations of the Porter frame, you will need to make sure every single bolts and nuts are properly bolted. It will be good for you should you need to construct your own Porter frame in order for you to simulate the loads, run some analysis or modeling to predict the capacity of the Porter frame, ensuring the Porter frame's capacity is not exceeded during the testing of the specimen, as well as you will need to consider the movement of the Porter frame, which can result in inaccuracy in terms of the loads being applied onto the specimens. There is a limit in terms of the deformations of the member, which is normally not exceeding 2 to 3 mm, as this kind of movement can lead to mislocations of the hydraulic jack system, which under significant load, the entire thing can damage, or the hydraulic jack can fall out, and this can lead to disaster during the testing. Again, when you want to construct the Porter frame, you will require close supervisions by the lab technicians. Let's say now you need to construct your own Porter frame, and the standard sections assembly might not be applicable to you. For example, these elements, which needs to be custom made, because you will need to fit the holes along the member, and the typical C channel system here cannot perfectly fit all the holes here. That means you will need to do a 3D modeling, pinpoint the exact locations of the bolt holes, and then fabricate in accordance to the intended locations, so that when you install in the laboratory, it will fit just nicely. You might also need to do some simple check in terms of the shear capacity of the bolt holes. How many bolt holes are required? Whether the connections of the portal frame is able to resist the loops acting onto the specimen. It will be good that you use up all the bolt holes available within the connections.